The mystery of the green liquid in the goldfish's stomach, dissected under a microscope. This is what happened. Have you ever been cleaning a goldfish and accidentally ripped open a small pouch in its stomach, only to see a thick green liquid leak out? Well, that's why we decided to unravel the mystery of goldfish bile. We'll reveal everything in this video. Brace yourselves, because we're about to dive into the microscopic world of goldfish bile. Part 1. From market to preparation table. We deliberately chose an intact fish because we wanted to observe its internal organs in the best possible condition. We found a dark bluish-green, translucent sac filled with a dark fluid. It was the goldfish's gallbladder. And indeed, when the sac was torn open, a thick, dark green fluid poured out. The color resembled very thick forest moss. Part 2. The first miracle, the disappearing green. When the microscope light is dimmed, the dark green appears to gradually turn yellow. This is an optical illusion. When the microscope light is dimmed, it produces light with a warmer color temperature, with more yellow and orange in the spectrum. When this warm, yellowish light penetrates the green liquid, the two colors mix in our eyes, producing the sensation of yellow. Part 3. The mysterious silver balls and the grain inside. We see small spheres. Some are yellowish, just like the color of the surrounding fluid, and there are silvery spheres that are not filled with fluid, filled with small particles like micrograins in gray and brown with various shapes. Some are round, oval, and even irregular. It turns out these are fat droplets, or what are called lipid droplets. Bile itself functions to break down fat. When the gallbladder is ruptured, bile fluid, which already contains bile salts, immediately begins to emulsify fats that may come from the remains of cell membranes or from the fish's food. These fat droplets separate from the water and form perfect spheres. Why do they appear silver? Because fat has a different refractive index than water. So light that hits it is reflected very strongly. Then the small, seed-like particles inside are microcrystals of bile salts, cholesterol that has begun to precipitate, or clumps of bilirubin and biliverdin pigments. Part 4. The imperfect sphere that holds a story. It looks like a ball. It's not perfectly round, following the basic color of the fluid, which is yellowish. These are epithelial cells that have been released from the inner wall of the gallbladder. When the gallbladder ruptures, the cells lining it are released into the fluid. These cells absorb bile pigments, giving it a yellow appearance. The imperfect shape is caused by physical damage during the rupture. Part 5. Solid red rock, congealed blood. There's a solid, deep red lump at 036. It's blood red, not transparent. When the gallbladder was removed, the dissected goldfish was still bleeding from the incision. There may have been blood dripping and mixing with the bile. So what is this red stone? It's a blood clot. Blood, which was originally liquid, immediately forms a solid lump when it mixes with the bile and is exposed to air. Part 6. Brown-black stone with mysterious spots. There's another object. It is blackish-brown. At 039, there is a larger dark brown spot at 311. This is a micro-gallstone, or pigment gallstone. This stone is formed from deposits of bile pigments, especially bilirubin that crystallizes and mixes with calcium and mucus. The brownish-black color indicates the oxidation of bilirubin. The longer it is exposed, the darker the color. The large brown spot is a semi-solid clump of bile pigment, a mixture of mucus, dead cells, and pigments that have not yet completely hardened into stones. Part 7. Red mucosic membrane, the following living tissue. Between the fat globules and crystals, we see a thin, reddish membrane at 104. The membrane is speckled with red spots. These are pieces of the mucosal layer. A mucous membrane rich in blood vessels. The source could be the gallbladder wall itself or the foregut tissue adjacent to the bile duct. When the gallbladder is torn, a small portion of the connective tissue lining it is also torn. Part 8. Spheres that crowd but never meet. The multitude of fat globules we see today are crammed together. They collide, stick together briefly, but never merge. Bile salt molecules have two sides. One side favors fat, The other side favors water. When bile salts encounter a fat droplet, they immediately surround the droplet surface. In the scientific world, this process is called emulsification. Part 9. Mysterious movements in liquids. See the tiny dots moving very slowly at 450. This movement is called Brownian motion. In a liquid, water molecules are constantly moving randomly due to heat energy. Although the water molecules are too small to see, they constantly collide with fat particles or droplets from all directions. Because these collisions are unbalanced, the small particles are pushed around. Part 10. Membrane with red Vibra webbing. Not nerves, but blood vessels. A membrane is visible, its entire surface woven with red veins. The red color indicates the presence of hemoglobin, or blood. True nerves are usually yellowish-white or grayish. This red webbing is a network of blood capillaries, part of the mesentery or peritoneum, a thin connective tissue that hangs and encloses the intestines and internal organs of the fish. This membrane is rich in blood vessels that supply oxygen and nutrients to these organs. When we remove the gallbladder, this membrane is torn. A drop of green liquid actually contains an extraordinary universe. This experiment teaches us that science isn't complicated if we have the determination to learn it. If this video amazes you, don't forget to like, subscribe, and turn on the notification bell so you don't miss the next microscopic exploration. See you in the next video.